All right, we're going to take a look at problem 21. First things first, or first part of the problem, it says state the possible positive, negative, and imaginary zeros for each equation. So that's Descartes' rule, and I'm just going to label it part A for now, so it's kind of easy to see. But remember, we want to count the number of sign changes in my function, okay? So that's the first step, is to count the number of sign changes. So the number of possible positive zeros in this equation are 1, okay? That's all we got there, all right? If I look at negative x, I'm going to have a negative x to the 5th plus 2x to the 4th minus 3x cubed plus 6x squared plus 40x minus 80, all right? So kind of looking at this one, we have 1, 2, 3, 4, all right? So the possible number of negative roots in this case are 4. Keep in mind the number of sign changes is always related to the maximum number of possibilities, but we could have imaginary answers. So what we want to do is we want to start at the maximum of 4, and then we can decrease in increments of 2 because our complex answers, or imaginary answers, always come in pairs, all right? So then our last step is figure out what the combinations work. Keep in mind I have a degree 5 polynomial. So I could have 0 imaginary solutions. I could have 5 real. I could have 2 imaginary solutions. 1 plus 2 plus 2 is 5. I could have 4 imaginary solutions because 1 plus 0 plus 4 is 5. And that's the first part of the expression. The second part is going to be find all the zeros in this problem, all right? So kind of looking at things, we have 6 terms. Could I potentially group, all right? So we wind up with x to the 5th plus 2x to the 4th plus 3x cubed plus 6x squared minus 40x minus 80. Well, that's an interesting question. We do have 6 terms, so normally I could do synthetic division, which you are welcome to do, okay? Or I'm kind of looking at this and I'm seeing those numbers work out really nicely for me. So I can factor out an x to the 4th. I wind up with x plus 2. In my next group, I can take out a 3x squared, and I wind up with x plus 2. Then I can take out negative 40, and I wind up with x plus 2. Notice all my groups are the same, so it worked out nicely. So I have the expression x to the 4th plus 3x squared minus 40, and then we have x plus 2. So then I want to continue factoring, and this one we actually probably can do in our head. We don't have to expand and group from there because the factors of 40 that give me 3 are 8 and 5. So a positive 8 and a negative 5 are going to give me that expression. So I know that one of my answers is negative 2. If I set this one equal to 0 and solve, I would add 5 and square root. So I know that 2 of my answers are going to be plus or minus square root of 5. And then with this one, I'm going to have imaginary solutions because I'm going to have x squared equals negative 8, which means when I square root it, 8 is 4 times 2. So I'm going to wind up with plus or minus 2i square root of 2. And those are your 5 answers to this polynomial expression. Again, you didn't have to factor. You could have gone to your calculator and used synthetic division on that problem. You would have seen your graph cross at negative 2, and then at that stage, you would have had to factor to finish that problem off.